Hello viewers, in today's video we shall be looking at how to derive the equation of motions. Okay, so let's start. um, Recall that we have basically three equations of motions. Okay, but most times it is always good for us to know how to derive these equations other than trying to do a kind of a cram work. It's better for us to know it and know why they are what they are. Okay, now the first thing we're going to do is um, let's remember that speed, okay, is equals to um, distance, right, over what, over time. Okay, now um, from here we can get what is called average speed. Okay, um, now speed is equals to what, is equals to distance, as I'm trying to cross multiply. Okay, distance, but you know, in physics we represent s with for distance we can still use x to depict distance. Okay, so distance is equals to um, average speed, okay, um, times time, right? Yeah, if we cross multiply, this is distance, this is speed, this is time, this is average speed times time. That means that distance is equals to what, average speed is what, v plus u over what, 2, okay, bracket what, t. Remember that v is final velocity, u is initial what, velocity. Now if we name this, let's name this our equation number what, number 1. Okay, now we also know that acceleration is equals to what, final velocity minus initial over what, t. Okay, then we can call this equation what, equation 2, right? Now from here let's make v the subject by what, by cross multiplying. We have that v minus u is equals to what, at. So v is equals to what, at plus u. Okay, 80 plus what, 80 plus u. Let me put this in the rectangular box. Okay, now I can call this my what, equation what, equation 3. Okay, so v is equals to 80 plus u. This is actually the number 1 equation of what, motion. Okay, now if we substitute this v, okay, if we substitute this v in this one, okay, so let's say substitute v into what, into equation what, equation 1, into equation 1. Okay, so anywhere we see v here we put what, anywhere we see v here we put this. Okay, so we have that s is equals to what, s is equals to at plus u plus what, u again, all divided by what, 2 times what, t. Okay, so this means that s is equals to what, u plus u is 2u, so you have at plus 2u, right? Okay, over what, over 2 times what, times t. Okay, let's, because addition is commutative, so let's bring this to this place. So you have s to be equals to what, 2u plus 80, right, over what, 2, all close. We have what, about t. So s is equals to what, s is equals to t times this what is 2ut, right, then plus 80 squared, all divided by what, by 2. if you split that fraction, we have s equals to 2ut divided by 2 plus what, plus at squared over what, 2. So this can cancel this, right? What is left? We have that s is equals to what, ut plus at squared over what, over 2. Okay, let's call this equation what, equation 4. Okay, let's call that equation 4. Now if from this equation what, from this equation, now this equation, this one, from this equation number 2, okay, from this equation 2, let's see if we can make t the subject of the formula here. Okay, let's see. So we'll say from equation what, equation 2. Okay, our equation 2, we had that a is equals to what, v minus u over what, t, right? Now we want to make t a subject, so let's cross multiply. We have that a times this one is 80 is equals to what, v minus u. So we have that t is equals to what, v minus u over what, over a, right? Okay, let's call this our equation what, equation 5. Now let's substitute t into equation, let's substitute this into equation 1, okay. Hope you still remember equation 1, this one, this equation. So anywhere we see t here, we put the value of what, of t that we have gotten there. Okay, so we have into equation 1, let's put this very well. We have s to be equal to what, v plus u over what, over 2 bracket what, t. This was our equation 1 that we got, right? And then we now have that s is equal to what, v plus u over 2, and close this bracket, yes, our t which has been gotten to be what, to be this, right? That is v minus u over what, a, right? Okay, now from difference of 2 square, we have that s is equal to what, v squared minus u squared all over what, 2a. If I cross multiply, this, okay, I have v squared minus u squared equals to 2as. If I take this to this side, I have v squared equals to what, 2as plus u squared, right? So my v squared will be equals to what, u squared plus 2as. Remember I said that addition is what, commutative, so this can come here and this one will come over. Okay, so this is now our equation number what, equation number 6. Okay, and this equation number 6, let's also put this in a box as we did the other time. Okay, and then let's equally put this one in a box. This one we are putting in the box is our major equation of what, of motion. Let's highlight this. Is the first one. The first one says v is equals to what, at plus u. The second one says s is equals to what, initial velocity times time plus what, at squared over what, over 2. And the third one says that v square equals to what? U square plus 2as. Okay, so this is the end of our today's class. Okay, recall that we state that the summary we say that the first equation of motion is what? That v is equals to what? U plus at, and then number 2 we say that s is equals to what? Ut plus half at squared, and then the third one we say v squared is equals to what? Is equals to u squared plus 2as. Okay, this was what we learned. This is a summary of it. Okay, these equations are very, very important, and this is mostly used when the body is what? When the body is not going up. Okay, when the body is not going up, it is mostly when the body is what? When the body is coming down, that is under gravity. Okay, and whenever the equation is being asked, the equations at times they may sound confusing, but what you do is you just take note of something, that v is standing for final velocity. Okay, remember velocity is always in meters per second, and then u is standing for what? Initial what? Velocity, also in meters per second. A is always acceleration due to what? Due to gravity, like I write it to it. This is always in meters per second square, right? And then s stand for what? Distance, which is always what? In meters. What again? Parameters are what? Okay, we are left with time. The t is what? Time. It is always in seconds. So if you look at the parameters in equations of motions, we have basically 5 parameters. Okay, 5 parameters. However the equation comes, don't be confused. 5 parameters. So when the equation is being asked, check out for the parameters that are given and the ones that are not given, then find the ones that are given. Also remember that if a body starts from rest, okay, see this marker here, as this marker is like this now. Okay, if this body starts to move, okay, the initial velocity of this body, as it starts from rest, whenever the equation says, whenever equation is saying in this topic, equation is saying that a body starts, okay, starts from rest, remember that this u here is always what? 0. Okay, whenever the equation says the body starts from rest. Okay, but when the equation says the body comes to rest, okay, comes to rest, let's do it this way. Starts from rest, okay, implies that u is equals to what? 0. Now when the equation says that the body comes to rest, okay, implies that v, final velocity, is always equals to what? 0. Okay, so with this I hope I was able to explain to us one way or the other how to derive the equations of what? Motion, and also how to understand the intricacies as associated with how the equations always come. Okay, and with this we've come to the end of today's videos. So if you find it if you are impressed, please like our videos, subscribe, and also share it with other scholars. Thank you.